In this video, we're going to be talking about ratios. So in that last video, we simplified fractions. And a ratio can be a fraction. It can also be some other things. But basically, a ratio is comparing two things. So a ratio is a comparison. We can compare more than two things, but usually not. And a ratio can be written in three different ways. We must also simplify ratios, but usually we want ratios to always be written in the same units. And what I mean by that is if I compare 1 foot to 6 inches, these are not the same units. I'm using feet and inches. I can't do that if I want a ratio. So I need to convert either feet to inches or inches to feet. I think in this case it would be easiest to go to inches. So there are 12 inches in 1 foot. So I write 1 foot as 12 inches. And I keep 6 inches on the bottom. But ratios must always be simplified if possible. So we need to reduce this. So I would eventually write 2 to 1. Or 2 inches to 1 inch. Okay, so make sure that ratios are always written in the same units and that they're always simplified. Alright, we can write ratios in three different ways. We just saw one as a fraction, right? So here's another example of a fraction. 2 to 5, that's how we say ratios, 2 to 5. So it could be in fraction form. We could say it using our words. We could say 2 to 5 and use the word 2. And we can also, instead of writing the 2, use a colon. This is a colon, not a semicolon. Let's see if I can do it. There we go. 2 to 5. Okay, so those are the three forms that we can write ratios in. And again, each form needs to be simplified and in the same units. Okay. Ideally, you always want to write your final ratio in the same form that it was given, or the same form that the question is given in. So if you see a ratio given to you as a fraction, your answer should be a fraction. If you see ratios given to you using words, then make sure you use the word 2. And if the problem is using a colon, then your answer should use a colon. So just use the same form as given to you in. Alright, let's try a couple here. Let's say I'm given 8 to 12. Well, we got to simplify it. So if I divide top and bottom by 4, then I'll get a simplified version. So we get 2 over 3, or 2 to 3. And my answer would be in fraction form because it was given to me in fraction form. Let's try another one. Let's try 3x semicolon 3x to 27. So sometimes when you're having to simplify things, it's easiest maybe to put it in fraction form to simplify and then change it back to the form that it was given to you in. So if we write this as 3x over 27, maybe that's easy to simplify. If we just divide top and bottom by 3, because that's the greatest common factor, then we're left with x over 9. And so we would have to say x colon 9, or x to 9. That would be our final ratio, because it was given to us in colon form, so our answer needs to be simplified in colon form. Okay, so let's see if we can apply ratios to geometry here. We can always use ratios to compare two or more things. So for instance, we have a parallelogram. Think back to our properties of parallelograms. We can write ratios comparing sides. We can write ratios comparing angles. Doesn't matter. So we're asked to write the ratio comparing side ZO to side DI. Okay, well ZO is 15. So I got 15. Well, what do I know DI is? Well, in parallelograms, opposite sides are congruent, so this is 15 as well. So I have a 15 to 15 ratio. And I'm going to use word form because that's how the question was worded. And then I simplify. Well, 15 over 15 would reduce to 1 to 1, right? So 1. This is a 1 to 1 ratio. That would be my final answer. Let's write the ratio of OI to ZD. Okay, well, OI, always give the thing they want first. They want OI first, so 20 would come first. And 20 to 4A. Okay, well, let's simplify that. Let's see, 20 over 4A is how we'd write it as fraction form. And then if I divide by 4, it's a division. Kind of hard to write there that small. Put a dot. Divide top and bottom by 4, we get 5 over A. So I would have to write my final ratio as 5 to A. Okay. So the same form is given to me, word form and reduced. What's the ratio of angle D to angle O? Preferably we'd be given at least one angle. Kind of forgot that at the beginning. There's 48 degrees, that's angle D. So opposite angles are equal, so we know O is 48 degrees. So my ratio would be 48 to 48. And that reduces to another 1 to 1 ratio. Alright. So again, write your ratios in the same form as given to you. And always simplify. Okay, so that's pretty basic. We got one more thing we can do with ratios. We can compare 3 things or even more than that. But we can use it to solve a word problem such as this. If I know that I'm dealing with a triangle and I know that the angle measurements are in a ratio of 2 to 5 to 5, or sorry, 2 to 2 to 5, then I can find the measurement of each angle. And the way to do this is to assign a variable to your ratio numbers. So I have 2, I'm going to assign it x. We'll say it's a 2x to 2x to 5x ratio. Okay, and you can put that in your triangle if you want to visualize it. Those two angles are equal. They're going to be 2 times whatever x is. And it's going to be 5 times whatever x is. So we know that all of the angles inside a triangle add up to 180 degrees. So if I add up all these like terms here and set it equal to 180, then I can solve for x. So we got 2 plus 2, that's 4, plus 5, that's 9, 9x. If I set it equal to 180, I can solve for x. I can divide by 9. Well, 18 divided by 9 is 2, so let's put a 0 on the end there, and we got 20. So if x is 20, that's not the answer to my problem. I need to now substitute 20 in for x, and then I'll get my angle measurements. It's 2 times whatever x is. That's this angle measurement. So 2 times 20 is 40. It's an angle measurement, so it's 40 degrees. Same thing here for angle 2, 40 degrees. And then 5 times x. 5 times 20 is 100, so 100 degrees. Do these add up to 180? Well, 40 plus 40 is 80, plus 100 is 180, so yeah. And maybe you're asking, why did I say angle 1 was that one? Well, we just go in order. So the first one mentioned is angle 1, second one's angle 2, and the third one would be angle 3. So there's a variety of problems we'll see dealing with this type of problem here. But basically the steps are: assign a variable to your ratios, think about how these numbers are related, and then try and solve for x. And then once you have x, substitute it back in, and you get your angle measurements or your side length measurements or whatever you're solving for. Alright, so that's a basic intro to ratios. Next up, we're going to get into proportions. Okay.